By this point, we're pretty much done with the recycle view and with the rest of the basic setup, so we can move on to the final major tasks ahead, which are going to be first planning and then implementing our database. So we're going to be using Android's SQLite database rather than the other ways of storing data for a few reasons. The SQLite database is quite lightweight, which means it doesn't take up a ton of room and doesn't require a ton of extra kind of setup or anything like that. It's actually fairly easy to set up once we get going, once we know what we're doing, which also means that it's quite easy to use. And also I'm very familiar with it, so it's just easy for me to explain rather than the other types. I figure in this section we can focus first on just creating the schema, so planning out how we're going to store the data, planning out what kinds of data we're going to store, and kind of what tables we're going to put everything in. And then in tomorrow's lectures, then we can focus on implementing the actual functionality behind the database. This way you get a little bit of time to kind of think about what you're doing and maybe even try some of this stuff on your own. So we're going to create a couple of classes to help us to both implement how the database is going to work, so the schema, and then the actual functionality. In fact, the schema of the database isn't going to be in a class, it's just going to be in a Kotlin object, which is a little similar to structs in other languages. So let's create one of those now. We'll just select a new Kotlin file or class, and we'll select an object this time rather than a class. So let's just call this something like database info, as this is not going to contain any of the functions. It's basically just going to be a series of constants and a bunch of information about the database itself. Okay, so generally speaking, we may have multiple tables depending again on how complex our app is and the data that we want to store in it. Our app is actually relatively simple. We just basically will need one table that contains all of the information about our to-do items. We could literally call this table to-do items table or something along the lines of that, and then we have to determine what kind of data we want to store in it. So in my case, there will probably be three major pieces of information I want to store and keep track of. One will be the name of each to-do item. One will be the date at which each to-do item was created. So these are both strings or can be stored as texts. And the third is going to be whether or not that item is urgent, whether it needs to be done urgently or not. This is a Boolean value, but I think I'm going to store it in my database as a number, so either a 0 for false or a 1 for true. So that's going to be step number one, determining how you want to represent your data in the database. So your schema might look a little different from mine. I'll just show you how I would do it, and then you can kind of alter yours to reflect the changes. Now, because we might have multiple tables in our database, I mean, we won't really, but better to get into good habits now, we're actually going to create an inner object, which is going to be all of the table info, okay? If we had multiple tables, let's say one for items, one for, I don't know, something else, then maybe we'd want to call this one items table info and the other something else. And probably spell info correctly would be helpful. And at each of these tables is going to implement what's called base columns. So that should add that import up there. So base columns is just going to be a nice way to store each of the kind of new rows in a table, and it's going to automatically assign an ID. So if you've never used SQLite before, I'll just quickly explain a little bit about how data is going to be stored in SQL tables. So basically a table represents some kind of an entity, or in our case some kind of an object. Therefore we have a table full of to-do items because each of these to-do items is its own object with some data. Now, each of the kind of fields of this to-do item is going to be stored as a column. So this means for each of the to-do item objects, we'll have a column that will represent the names. We'll have a column that will represent whether or not those items are urgent. And then we'll have a column which is just going to represent the dates again as strings. Now, each new entry into the table can be considered a new object. So basically in our starter here, we have three objects. One's buy groceries, one's do laundry, one's play guitar. And so these would be three different rows in our table. And for each of them, we would have, I don't know, I guess the date would have been today's date. And we'd have false for urgent, true for urgent, false for urgent here, and then obviously these names. That's how our data would kind of be stored. So we want to think about our data being stored in this table-like format. So that means I'm going to create first a constant to represent my table name. So let's make a constant value. Let's call this table name. And I'm just going to call this something like to-do items table. You can really call this whatever you like. And now we're going to store each individual column. So I have a constant value, let's call this column. I generally precede each column with the word column. And let's call this item name. This is just going to be equal to something like item name. We'll have a constant value to represent the column. Let's call this item urgency. And it's just going to be called item urgency. These are just kind of the names of each column. So again, think about the table of data. Each of the columns will have a name. Each of the rows will have some kind of an index. So probably start at 0 and go until, in our case, just 3 or however many items we want. And finally, we'll have one to represent the date. You may or may not have the date. Probably a good idea to store it now if you haven't already, because we'll probably use it in the next couple of sections. If not the next section, then the very last section for sure. So I'm just going to call this item date. Okay, good stuff. So this is kind of how our table is going to be looking. We have the name and then the 3 columns along the top here. So just make sure your database has all of the necessary columns. So 1 column per piece of information you want to store about a specific item. So now I might as well actually put the queries in here rather than in the database functions class. So we're just going to create a couple of values. One is going to be a query to create a table. I'll explain exactly what that means in just a second. I'm going to call this SQL for SQL, create table query. Okay, and I'm just going to fill this in with a blank string for now. I'll give it a real value in just a second here. I'm also going to create one for a delete table query or a drop table, whichever you'd like. Okay, and these are pretty straightforward, exactly what they're going to be used for. So within these strings, we're going to have to put some actual SQL code. Now, luckily for us, we don't actually need to know a whole lot about SQL. We just really need to know the SQL for creating and deleting tables. So for us, for creating the table, this is going to look something a little like, in fact, we can get rid of that. This is going to look a little like create table, and spelling and spacing and everything is very important here. If we mess up even a little bit, then we're probably going to get some kind of errors thrown. So we want to pass in the name of the table here. So we're going to put the $ because this is a string interpolation. And then we're just going to put table info dot table name. Okay, so now we're creating this table. We're going to have to put in an open bracket here, then a plus, and then we're going to continue this string. Okay, so in here, we're going to take in the ID from our base columns. Now, you can't see an ID here, but base columns automatically assigns an ID. So we're just going to get our base columns. Whoops, this should actually have the $ there. Base columns dot underscore ID, so you can see, just contains a little bit of information about the columns. And then this is going to be stored as an integer, and this is going to be the primary key. So we don't need to know a ton about keys, really, to continue, but just recognize that we're going to be kind of storing each item under a unique key. So that's just a way to identify an item, because we could have items with the same name, the same date, and the same urgency setting, but because each one will have a unique ID, which is a unique key, they'll be stored in a different location. Okay, so we have that, and then we're just, you know what, I'm just going to copy this to make things a little easier, a little faster. So rather than the base columns ID, we want the rest of our column names. So now we want the column item name. So let's just set table info dot column item name. This is not going to be an integer primary key. This is actually just going to be represented as text. Oops, that should be capitalized. So text, and I totally changed the wrong one, didn't I? Okay, so yeah, let's just do this for here. So this will be table info dot table name. Okay, so again, this is just going to be text here. This is the type. It's just going to be text. Doesn't really get stored as a string. It's text, which is just a way of representing a string. So let's copy this. Paste it. So next up is going to be, I'm not sure why I said table name. We actually want the column item name. Kind of been a long day. Okay, so we've got the item name, then we'll want the item urgency. Okay, and then finally we'll want the date. So let's copy and paste that again. Just bring it back. And so we'll want the column item date. Now, we're going to store this last one as a text. So rather than having this comma, we're going to open up with this, and we can get rid of that plus to solve our issue. So I've actually made a mistake here. Can you spot it out? If you didn't manage to spot it out, it's going to be this guy here. This should not be text, because I said earlier that I want to store my urgency as a number. So I'm just going to store this as an integer. That way I can store it as either a 0 or a 1. I could really have stored it as a true or false if I'd liked, but I think a 0 or 1 is a little better. So this statement right here is essentially telling our database what a table that is going to represent basically our to-do items table, what this is going to look like. And it's saying here that we're going to have 4 columns within this table. One is just going to be an integer primary key, which is just the ID. Again, just a way of representing, or rather a way of identifying each unique item. Each unique item will have a unique ID. So the next column is going to be the name. We're specifying that it's going to take in text types. The next column is going to take in integer types. It's going to contain our urgency. And the last column is going to contain the column date, which I'm storing as a text. We want to close this off with the bracket here. Now keep in mind, this create table query is actually not going to be called every time we put information into the table. This is actually only going to be called, well, once, depending on if we update the table, then it's going to be called again. But essentially, if we are just storing items, if we're just adding information into the table, we'll call on some different operations. This is just going to be called once when we need to create a new table that is going to contain a new set of data. Okay. So with our create table query done, we'll need to move on to a delete table query. Generally, you do want some way to delete a table and some way to create a table. This is actually going to be much easier than before. This is just going to be a simple drop table if exists. And we're going to pass in the name of the table, which is just going to be our table info. Actually, which should be $table info dot table name. Okay, so simple as that. So we can save this, and our database info object is actually done now. So the next task ahead of us is going to be just to create the database, and let's call this database operations or something class. And we're not going to implement much within that. I'm just going to kind of explain how we'll go about implementing that, give you something to think about, and then when you come on back tomorrow, then you can start, or then we can start implementing it together. So let's create a new Kotlin file or class. This one is actually going to be a class, not just an object. I said I was going to call mine database operations, because it's pretty indicative of what this is going to do. Now our database operations class is actually going to be a subclass of SQLite Open Helper. SQLite Open Helper contains most of the methods, or at least provides us methods we can override, and that we'll need in order to actually carry out the database functions. So, although we'll still need to implement our own custom methods, it has, like I said, the built-in background methods, variables, classes, all of that good stuff that we'll need so that we can not worry too much about the hardware side of things. So we're going to extend the SQLite Open Helper class. Okay, and there's going to need to be a few things that we'll have to add. First of all, in our primary constructor, we'll have to add a context. So let's just say context of type context. And in our SQLite Open Helper, we're going to have to override this constructor by passing in first the context that we'll pass in here, and then we're going to have to pass in a few more items. Now we actually don't have these items yet, so let's create a companion object to hold some of the information. It's just going to be a companion object. First of all, we'll have a constant val, which is going to be the database name. So we can set this equal to whatever we want to call this. I'm just going to call mine something like todoitems.db, which is going to represent the actual database itself. And we'll also have a constant val to represent the current version of our database. So I'm going to call this database version. This is just going to be version 1, or you can say version 0. I would start with version 1 though. So every time we update our database, you simply change this number, and that reflects all of the changes for you. What this does is if we write the code right, it will completely wipe everything, and then it will rebuild our table, but it won't keep any of that old data. So if we update the database version, it will basically clear the table, it will create a new table, and then we'll have to start by populating all of the data from scratch again. Okay, so be careful when you're updating the database version. So now we can pass in the rest of the variables here. We'll start with the database name. Then we'll have null, so this is a factory object we don't need to worry about. And then we'll have the database version. Okay, so now this is still giving me errors. The errors here are the fact that we need to, I'm just going to put this on a new line, that we need to implement certain methods. So actually, we can hold Option and Enter, and it should actually bring up the option to implement these members. So we're going to say OK, and we're going to also implement the other one, Option Enter, and that's going to be our upgrade. So we'll have an onCreate and an onUpgrade. I'd rather actually have them in a different order, and I'd rather put this companion object up at the top here. Okay, good stuff. There's also the optional onDowngrade, which I would rather implement anyway. We don't need it, but it's good practice too. So we'll have an onDowngrade as well. And for now, it's just super onDowngrade. We'll kind of modify that a little bit. Alright, so I think this has actually been a pretty long section and it's gone on for a little longer than I want, so I'm actually going to end it here. What I want you to think about, and I'm not really going to assign too much homework, but I do want you to think about is going to be what kind of operations we want to perform. Typically this will be add, modify, fetch, and delete, so we'll probably need those 4 operations, and think about not necessarily the core implementation of those functions, because you haven't learned that yet, but think about what we'll need to pass into those functions. So for example, let's say I'm adding a new to-do item to my database. Well, likely I'll need the name of the item, I'll need the current date, or perhaps I could even calculate that automatically, and likely I'll need whether or not the item is urgent. So those 3 pieces of information at least. The ID is actually auto-generated. Same with when we're upgrading, or I guess a better word would be changing or modifying an item. Think about what piece of information we'll need to pass in. What about when we're fetching the items? How are we going to retrieve them? And so on and so forth. So just give a thought. If you want to try to add some of the method skeletons, that is totally cool, and I would actually encourage you to do so. But just note that the implementation is, going to be a little trickier than you might expect, just because we're going to be using some interesting stuff like cursors and content values and instances of SQLite read and writable databases. Okay, otherwise we're just going to do a really quick summary coming right up. That's just going to be a few minutes, just going to go over what we covered for today. If you want to skip over that summary, totally cool, and we'll see you tomorrow. Otherwise, stay tuned for that. I'm just going to delete this. Yeah, there we go.